Hello friends, today we are going to discuss about multilinear regression and how to test assumptions in RStudio. My name is Dr. Neeraj Bali. I am from Voleka University, Department of Management. So basic idea is just to give a demonstration at how easy it is to check all the assumptions in RStudio. So we start with our basically the model is to predict the salary. Salary is the dependent variable, and based upon experience, age, and leadership qualities, we try to predict salary of a person. And so basically leadership, age, and experience is independent. They are independent variables, and salary is the dependent variable. So first we will install some packages. You have to install it once, but because you may not have installed, so I'm just writing the command. So it will prompt you the command. First is to read the file of data. This read R should be in us. Second package which we want to install is less R other package. This if you have already downloaded these packages, we don't have to write, but I'm assuming that you may not have. One time only you have to download these packages. After that you don't need to. And this thing will work offline after you have downloaded packages. As I have already downloaded these, I will not run them again. This stuff. Then we will call upon these packages. First one is read out to read the database file. Second one is plus R for regression. Third one is R. We can run these all these libraries. Okay. Now let us set our working directory. We can go to the session. What is working directory? That is where your database file is, where your data is. That is your working directory. So we have to set that. We go to session. set working directory, choose the directory. So my database file is in the desktop, so I will select the desktop, just say open. So you can see here set working directory C drive. So desktop is set as working directory. Now let us import our you want to make it as a program. You can copy this and paste it on top. So that whenever the program is run, your working directory is set. That's it. Now let us import our database. From here we can import it. Import database. It is a CSV file. So from text, I will browse and select the file. Salary MLR1 is the name. You can see it is a CSV file, comma separated file. I will select this. And you can copy the code. Copy the file has come. I can cancel this. I don't want to import it because I want to change some things. Like for example, I copied the month. Library reader is already there. I delete this repetition. I want to change the name of the database. I have not imported directly from there. Just copied the commands. I will make this as data file data file. So basically what we are doing is we are opening this particular file, salary MLR1, putting it in the object called data file 1, and then we are viewing the data file 1. Now data file 1 is nothing but the salary MLR1.csv or Excel file or CSV file. The data file salary MLR1 is now in object called data file 1. So can we run it once so that we know that what is going on? Select this. Now you can see the file has been imported as dependent variable salary, independent variable leadership, age, and experience. So we are going to predict salary based upon experience, age, and leadership. Let's go back to our program. Working. You can see here data file 1 with 300 observation and 5 variables have been identified by the software. So it is already imported in the system. Now we go ahead with it. Now because we have used this library less r particular library, we can use command regression What is our regression all about? We regress we are having dependent variable salary. We try to predict to IVs, experience, age, and leadership. Salary is our dependent variable. These three are dependent variables. We go back. Quite simple. Just write first your dependent variable. What is dependent variable? Salary. Then tilde sign used to show that it is predicted by, salary is predicted by first age plus then experience plus leadership. Then comma, we write data is equal to data 5 file 1. So now what I want is I want to put this particular regression in a object. What I will do is I will put this particular thing where the arrow is going, it is put into an object. Let's name any name you can put. Let us name it as reg model dot 1 1. That is anything you can put, but I have taken this. And then I want to know what is there in reg model, so I will mention the name again. Reg model dot simple. Now let us run this thing. Is it working? Full enter. File 1 error. And we want to see what is there in reg mod 1. Let me run this. Okay. Now once we do this, we have some result over here. Some plots because of this command. Simple command is there. What is the command? Because of this one command, many things have come. The command is only regress salary by this age, experience, and leadership. So age, experience, and leadership is predicting salary. So we have written salary as a dependent variable. This tilde sign is to show that it is predicted by, salary is predicted by these three. So a simple command, and we are writing which data the command has to take. We write here data is equal to data file 1. Data file 1 is the object which is having our data. How this data file has come? I have named it. It can be data file 1, it can be anything. It can be db1, it can be file 1, anything. This is a variable. It is an object like a variable, and this particular data is in that. Now we say what is there. Regression model is in regmod 0.11. When I say regmod 0.11, it will display what is there in this. So what is there in that, in this particular regmod, the regression model? So all these things have come. We will just expand this so you can see what all has come. Basic analysis has come. Basic analysis which says that first we see the F statistics. It is significant, yes, less than 0.05 p-value. So this model is okay. Then we see R square, it is 26. Our adjusted R square is 26%, around 25.9. So it shows, that means model is able to predict 26%. 26% accuracy it can predict through IVs, the dependent variable. So this is what it is showing. Then this is our table, this is our estimates, this is a constant. Then we have some variables here, IVs. Basically it is saying that for 1 unit change in experience, there is 0.481 unit change in salary, keeping all other IVs constant. So this is a basic chart which you all have, you know it. Then there is also a confidence interval at 95%. You can see lower and upper. Now interesting thing is age is having insignificant p-value. That means p-value is more than 0.05. So age is insignificant here. We have to see why. And also it is showing in the confidence interval, because confidence interval minus 0.375 and plus 0.550. That means 0 is there in the interval. When 0 is there, it again proves. Okay. Yeah, this one collinearity VIF. You see this VIF for experience and age is quite high, more than 5. It can go till 10 also, but more than 5 is not good. Age and experience is high and leadership is low. So it also shows that age, maybe age and experience, if we see the matrix also, that particular command, even the diagram has come. We can see the plots. Okay. Particular plot. See, this is a correlation between the two variables. Age and experience is 0.93. Other all correlations are less. Less than 0.85 is okay. 0.85 or above is a point of problem. Age and experience again is showing high correlation. Maybe because when the age will increase, obviously experience will also increase. So both the variables should be put in this is not feasible. And it is age is insignificant, so we can remove age because it is creating problem in this model. So let us try to remove the model, or let us try to modify the model by removing age. Did you understand why I am removing age? First of all, correlation is high, VIF is showing high, and both are looking similar because age will increase, experience will increase. So let us see if what happens if I remove age from here. So it is insignificant also if I remove age from the model. Now let me run it again. See, now there is no problem, no 0.85, all are less. And also let me see the VIF. Let me see the VIF. Should be less than 5 actually. So no multicollinearity between the IVs. Old one. There's none. Done this. Now let us check the VIF again. Now see, variance inflation factor is less than 5, 1 or 1.06. Quite good. Now there is no collinearity, so we have met with the first assumption of multicollinearity is not there in the model. And also I have just one particular article which is very good. I will also put it in the comments. Yeah, is from this person, Mr. Mahmood. I like this article. It is talking about various assumptions of multicollinearity. Various assumptions of multilinear regression. So these are the assumptions. First is linearity. What is that one? Let us see. And linearity is what? The first assumption is very obvious and straightforward. Their variable that means linearity check between the variables. Variables should be linear. So which variables? Independent variables. Between the independent variables and response variables. See, check scatter plot of response variable against all independent variables. So let us IV and DV should be linear. So let us go and see this. Zoom. Let us zoom it. Yeah. The graph. Now, between DV and IV, it should be linear. Salary is DV, experience is IV. So salary, this is definitely linear. If you see the bands, they are showing the variance. Variance will increase, the band will increase. So quite linear, I would say. Then between salary and leadership, this one is again linear. So this particular assumption of linearity between IV and DV is met. They are linear. There is no problem. Let me close this. So the first assumption of linearity is met. Multicollinearity we have already spoken. Between the IVs should not be correlated. Between the IVs, the correlation should not be there. So VIF, it will say C should not be greater than 5. So ours is 1. So again, multicollinearity is met. Multicollinearity not there. This assumption is also next. Okay, let's go to the next one. Correlation we have already checked is less than 0.85% for all. One was above 85 and we have removed that age. So again we have checked there is no correlation, high correlation between the IVs. Even VIF value is less than 5. So multicollinearity is not met. Multicollinearity is not there. Next is homoscedacity. That means that the residual should be homogeneous in nature. How do we check that? There is a graph this one. Let me zoom it again. If you see this particular graph, the graph against the residuals and fitted values. Fitted values is predicted values by the model. So this particular graph should not show any particular trend. I mean, there should not be any like a triangle or like a U. There should not be any pattern of residuals which should be able to be seen in this particular graph. There is nothing like that. So we can say that heteroscedasticity is there, homoscedacity is there, and heterogeneity is not there. So it is homoscedacity assumption is met. It should be homogeneous. Residuals should be homogeneous. This graph has proven that. Let us go to the next assumption. See, there is a pattern here like a triangle. This should not happen. We don't have like this. Again, there is a pattern. A multivariate normality. This assumption states that the residuals from the model is normally distributed by QQ plot. So let us check that. So how do I make QQ plot? QQ plot is not there. So let me first make the residuals. Look at the residuals. So let me make one more in a object which is residual object dot one. Then I will put values in this object. Calculate the residual per command residual of the model. Model is in the object reg mod dot triple one. So I'll put the reg mod dot. Again I press Control Enter. So here it has come. See 300 is there because residuals are there. 300 sets are there, 300 residuals are. Let me see the residuals. Let us see res I. Let's say control. Okay, the residual. These are the residuals. See 300 residuals are there. What is the residual? The actual dependent variable is there. Actual observation is there, and actual dependent variable observation is there, and one calculation is done by the model. The difference between the actual and the calculated one, the difference between these two will be the residual. So 300 data is there, 300 residuals are, which are there now in this object resi obj1, as you can see here. Show you. See. These are all residuals. 1, 2, 3. All. Now I have calculated it. Now I have to plot them. QQ plot. These residuals should be on the line. Then it is okay. Normality. Normally distributed. It is on the line. Normally. can show us that. Let me make the plot. Just we have to write QQ plot of residuals. We have to plot the residual. Object one. This has just say there will come because we have already specified the working directory. Let me zoom this all. Not enjoying this. Increase this. Okay. New plot. Make this big. Let me make the plot. Now it has come. Okay. Zoom it. Why is not zooming? Taking time because there are so many programs running. I'm recording also. Anyways, show you. Yeah, so you can see this particular QQ plot. Most of the observations, the residuals are on the line, so it is normally distributed. Row number 201, row number 233 are outliers. So we have to look at these outliers and we have to remove them if they are by mistake come in the sample. But if it is not by mistake, then we don't do anything about it. But it is acceptable overall. So multivariate normality is met, this particular graph. Go to the next one. Now let us that's it. Let's go to our next assembly. So this one is okay, normal. See the QQ plot here. Okay, there you can also make a histogram of residuals. It is already made by us. There are two ways of checking it. Open this. What? This one. This one, this particular, okay, again I will zoom it. I don't know whether you can see it or not. Yeah, this one is the actual one. Should be like this. Computer as per the normality. But this one is our actual data. This one. So it is almost okay because exactly it will be like this, it will not be. So it looks like residuals are normally distributed. So again, this is another way of checking multivariate normality. We have checked in two ways. Okay, now we go to the next one. Okay, there is also autocorrelation logic, but in this particular article, it is not mentioned. For autocorrelation is generally in the time series data. Autocorrelation means that residuals will repeat themselves over a period of time. That should not happen. The Durbin-Watson test can tell us that whether autocorrelation is there. If it is 2, the value is 2, there is no autocorrelation. Autocorrelation should not be there. Residual. This is the last assumption. So let us do the autocorrelation test, Durbin-Watson test on the residuals. So Durbin-Watson test on the residuals again, RES. Object. Press Control Enter. The value is 2.14. Again, I said that 2 is the what is expected for no autocorrelation in the residuals, but 0.15 as per rule of thumb, 2.15, 1.85 to 2.15, 0.5 less, 0.5 above, 0.15 less and 0.15 above is acceptable. So it is less than 2.15. So again, autocorrelation is not there in the model. So our model is complete and it has met all the assumptions, all the assumptions of multilinear regression. So we can definitely go ahead with this model, and it is good fit. And all these data, everything, like for example, all learning data, all files, I will put it in the comments for practicing. If you have any doubt, please comment. And if you want to have any particular thing, any particular model or anything in the R, you can comment. Next, I am planning to do for panel data, time series data. That will be the next one. So please subscribe and like. Thank you.